go. Hopefully, here we go. Let's get this going. Welcome back. We are now using the webcam with the C program. And let's see how this is going. And it should be going now. Okay, so what we are using right now is the C program that we've done in previous videos, and if you have not seen those, you can go ahead and check out that channel after this live stream and see how it's going. But for right now, I realize that since making this or starting this C program, we have not tested any other peripherals. We've only used the X11 grab feature from FFMPEG. And for that, I wanted to use the webcam because I really don't have anything really. I could have been playing on a game using the RCA or something like that, or checking out the microscope. So I do have the AC off in my office because it is quite loud. And let me see if I can turn this around. Let's see if this is too bright. So it even with the AC being off for what, less than 2 minutes, it is already 78 degrees in my office. It was only about 74, 75 with the AC on. And while we're here, might as well talk about the temperature probe project that we have here. So recently, I took this to go to some locations and test it out. I brought it to the park, testing it out. And since then, well, you can't really tell here because this is actually quite bright, but the LEDs are dimmer than they were, and I did dim them with this. I don't think that's on screen. Hopefully that's on screen now. I did dim it with this current limiting resistor, but I don't know if somehow I changed something else with the resistance. And I do have a USB meter, but that USB meter is detecting no current, basically because it's not that sensitive, and I've gotten the current pretty low on this as it is. So things that I can do is hook up one of my external battery boxes, and if I can solder them better, and in there hook up the multimeter and check out the current draw. That is one option. Another option would be just to, connect one of these 18650s that I pulled out on a previous live stream and give that a check. These would not work because these are 2.4 volts, and these are dead anyway. This is for a cordless phone. I need to get new ones or figure out what type of cells are in here, and that might be my next thing, is maybe tearing one of these things open. So as of right now, everything seems to be working well with the live stream. The issue with the segfault, I believe I fixed by doing a flush of the fprint and also putting the buffer on the heap. But I'm leaning more towards it being an issue with the buffer, the fprint buffer, because what was happening was that basically fprint, I was using the /r instead of /n just to bring it back to the beginning of the line, so it wasn't printing line. It was just returning and reprinting, and that info is not actually needed, and it was only for testing purposes. And we should be back. Hopefully we're back. Okay. Everything seems to be back up and running. So we did drop it. So that was about 5 minutes. And as you can see here, the temperature has raised up to 80 degrees. I don't know. And I just realized I left my phone on, so if anyone decides to call me, it will ring now. So I turned that off. It's 80 degrees, but I am actually speaking right over it, so that could be partially my breath. So let's go ahead and put in 81 degrees. Let's go put this aside, and I'll check on that in a little bit. This might limit how long I do this live stream for. And also how long it takes for everything to crash. Now let me see if I can tell what caused it to crash. And temp pipe broken. Error writing to temp pipe, so that might be an issue with the buffer size to temp pipe, where things are getting fed into temp pipe faster than they can be pulled out, or vice versa. And I need to find a way to actually check that in the RTMP program. So let's go make some notes. So pipe break, check in RTMP. Is RTMP? I always get this mixed. I always get that reversed. RTMP. Yes, I got it correct. Module. Okay. So I'm gonna have to research that. Then we still want to merge the RTMP module with the GUI module. And before I do that, because what that's going to do is right now I have it going into test main.c file. What I ideally want is to get that to be a name of program. .c. And I'm not really sure exactly how to do that without a name of this program, so go ahead. I did put not quite a poll up. Let's see, what did I put up? Let me click here. It was a community post. So let me go. Oh, that's on the wrong count. Okay. So it was a community post. Can I click on just this post? Okay, so I got the post itself. Okay. Let's throw that in here, and I'll throw that in the chat. And that's the community post link that I put together to show basically asking for a name of the program. So we need, let me make notes, need name of program using, okay, so that's 1, 2, 3. We're going to move the FFMPEG functionality to C from scripts. And what this will allow me to do is then be able to merge this module, this FFmpeg loading module, into this name of program module. And when FFmpeg loads, we will have the PID of FFmpeg. And with that, we can kill the PID and go on to the next. Okay, we're back. Okay. So what I was saying when we got cut off is once we kill it, we would go to the PID and it would go to the next video source. So right now, I need to check something, but right now I forget how much I am using for each block. But the first time it crashed, it was at 579 blocks. Crash 1. Crash 2 was at 639. So I do not recall. Let's see. Let me go to the source directory. and see what size block I was using. And I am currently using 512K blocks. So block size 512K. And that gives us a little more data. And let's see. So we'll just say 0.5 megs. So 0.5 times 579 is 286 megs. And 639 times 0.5 is roughly 320 megs. And we don't know if we are going to crash again. But let's check some stuff out. Just give me a second. And it looks like we have one person watching currently. So if whoever that is wants to comment anything, let me know. So now, once we do this, we can have a fully functional program that is completely integrated with itself. So once we move that, then we integrate FFMPEG exact C, because that's what we're going to be using to get basically running that in a fork. In fork shown as a function, and then integrate that module. So then from one user interface we can have it run each individual video source, and also that will potentially limit what happens when the program crashes, because right now I have to keep an eye on it, which it's up to 437 blocks right now, so it could go any minute if something is consistent. Again, I don't have a way to check to see why that pipe is failing. And I will go back to the video screen. So part of the issue with the pipe failing might be that YouTube wants 250 kilobits per second or 2.5 megabits per second. I don't know why it doesn't just limit it to that, listed as that. And right now I'm at 6,356 kilobits per second, so I'd have to get FFMPEG to lower its bit rate, which I've played around with, but I still need to do some more fine tuning. So once we get all that together, if the program does crash and it's set to the last video source was with the webcam, it'll know to restart the webcam once we get that integration working better. So that's one thing that will happen, and we are currently at 579, which is where it crashed the first time. Let's see if we can get past there. And let me also check on some temperatures. So the temperature of the computer is 61 centigrade, which is perfectly fine. And the temperature in the office is still at 81, which is not comfortable. And we are at 539, which is where it crashed this second time. So we're slowly getting better, and I don't know what is actually causing those crashes. Then the next phase, once we integrate all that and get all that testing, is do video / audio codecs organically. So what that means is we are going to remove the need to run exact on FFMPEG. And just to let you know, it looks like we have 2 viewers right now, so welcome. Once we do get to that point, we will be able to not rely on that pipe, because that pipe is part of what is causing the issue, is feeding feeding data into the pipe and then taking that data back out of the pipe. And that is, again, causing a issue. So if we can do that completely internally in the program, we can better regulate what is happening. So this is what's going on with the C program, and hopefully we have a name soon so I don't keep calling it the C program. Now let's go over some other projects. And yeah, I'm spelling things all wrong. We are at 910 blocks. If we do crash again, I am going to run the countdown video while I do some testing, because that will help with some of the testing, is if that video is running, because that video doesn't seem to cause any issues, but then again it only runs for a minute. So other projects are getting this working. So the Pico wire wrap board completed. So these really don't need to be done in order, but that's one. Even some of the other stuff on the other side, I may start that FFmpeg stuff later, integrating into C, because again, that's going to help me fix some other items. So we are at 1024 blocks, so that should be 500 megs sent so far without interruption. So the next thing with the Pico is to complete the C C++ programming. Because all I did so far is on this Pico, I only put the ability to read the temperature module, and then it sends it out via the serial port, which reminds me of what else I can do. Set up R shell on the Debian laptop for set up the software development kit on the Pico software development kit on the Debian laptop. Okay, am I back? Don't know if I'm back. Yes, I'm back. Okay, so I just tried to reset the... Okay, so let me go back because apparently nothing I just said went through. So it crashed again at the 1,168 blocks. And is buffering, okay. Let me try to just fix something real quick. May take a minute. And I'm checking some other stuff out. Okay. Okay, sorry about that. So it crashed at 1,168 blocks, which is roughly double, just a little under double what it had done previously. And the countdown video, both times I ran it during the stream, was exactly 151 blocks. So I don't know if that makes any difference, but it's just something that I checked. But I don't know what is going on. So okay, so, oh, I just realized something. It is seg faulting. I just have not been seeing the seg fault because of the way the stream is, and maybe the next time it resets, I'll do the X11 so I can show you on the screen why I did not notice it. Because, well, basically the reason I didn't notice it is that it's currently says RTMP writing to stream block colon a couple spaces and then the number. And it, like I said, I'm doing a /R, so it just resets the line. So where it's saying segmentation fault goes right here. So I'm just seeing that, oh, two stream, blah, blah, blah. So it basically goes basically right up to here. So I wasn't looking back. So it is seg fault. And that I actually was able to get that because when I am running, say, the anything where I quit it, where I run and then quit, it puts out a print line as right before the program terminates, saying it goes to a new line and says program terminated. What did I say? Normally. So I actually added that so I can see if it ever gets to this point, and it does. I just doing the live stream and everything else and trying to troubleshoot stuff. This is why I actually do maybe in between each regular live stream that I do about 6 or 7 other. What the? That's weird. That is very weird. Let me see something. It is telling me that the live stream ended, and I don't know why it is saying that. Is the live stream live? There, it looks like it's live. Okay. That is the other problem. When this ends, if it doesn't buffer correctly, it just abruptly ends. So that could be an issue, and that could be why we're down to 1 person watching. Oh yeah. I need to fix this description. Okay, we're back up to 2 people watching apparently, so whoever got kicked off may have came back. So I have 2 versions of the RMTP. One is I compiled with -ggdb, and one that I did without debugging flags. I read somewhere that the seg fault happens only with the debugging version, so which is what I am actually running right now. So the next time it crashes, it may take me a minute, and I will go back to the no debug version. I may actually still run the video, just because I want to see if the no debug version has the 151 blocks also. And we're at 600 blocks, so let's see. So back to where I was before it crashed, and let's see if I can keep going, is that I want to set up the Pico software development kit on that Debian laptop, which is what I am running this live stream from. And then I installed VS Code so we can go ahead and do some VS Code videos. So other items is I have tried to fix / dismantle some electronics. And not even so much, well, they're use electricity, so electronics. So I have a 12 volt car air pump. Actually, I have 2 of those. One is a decent one. I bought a couple years ago, and then all of a sudden it just died. The cigarette lighter port or the power adapter port, whatever you want to call it, overheated. Okay, so it crashed again, and this time it crashed at, I should have left more room here. It crashed at 7:48. So with the RTMP module, I am running that with no debug symbols. And let's see how long that lasts. And I did a test with the video and I got 151 blocks, so that's still accurate. So what I was saying is I want to fix or dismantle some electronics. I have two 12-volt RC, two 12-volt car air pumps, and one of them is a decent one that I've had for several years, and I think I may have overheated it, or that the power port, the cigarette lighter port, was very hot when that happened, and I may have possibly blown a fuse, or I may have just fried it if there's no internal fuse. So I'm probably going to make a video where I take that apart and see what we can find. And then I bought a cheapy one off of AliExpress, and that lasted all of a half a tire, and that died. I do have another one that I may show. It's a battery pack one, so it's completely, you don't need to have it plugged in. It's also used to jump your car, which right now I am trying to desulfurize my car battery in hope that I don't need to buy a new one, but I probably do. But it could also be that the terminals are completely corroded and I need to grab my sandpaper and clean out those terminals. But that I probably won't make a video just because I don't have a good way to record outside except for maybe using my phone. So there's that air pumps. I do have some partially recorded and for an electric razor, but that just may be a goof video because I have it here somewhere. I don't even know where I put it. It's just, I wasn't able to figure out why it failed. That one could be that it was not dual voltage and I had it plugged into 110, so that could have just slowly killed the battery on it. It was a battery operated, was that one battery up? Yes, that one was battery operated, but it wasn't charging with the correct temperature. Oh, and like I said, these are not in any particular order, but I do have a Pico W, or possibly two. I have lost count of how many Picos I have bought and what kinds. So you have the Pico W, and let's go do a temperature check. It is 60 degrees Celsius in the computer, which I don't recall, and it is, what is this, 82 degrees Fahrenheit in my office. So these are all, besides the current series that I'm doing with the, with the RTMP program. These are other items I'm doing. Also, I will be most likely getting a computer together to install Debian Trixie, which is what is now the testing of Debian since Bookworm, which I have. If you haven't seen that playlist, let me see if I can find that playlist. Playlists. Here, playlist. So, let's see, copy link location. So this is the Debian Bookworm series that I did. And other playlists, if you go to the website, I do have a Legend of Zelda playthrough. Just this was early on in the channel, but I may do some other video game stuff. I have the Raspberry Pi Pico, which I am thinking of removing the live streams, which, yeah, this wouldn't really go on this chart. Taking all the live streams out of that video and make it in its own playlist. And then from there, so the Raspberry Pi Pico, I think, has 26 videos. I think 3 of them are playlists. So it makes it a little bit more streamlined. Okay, welcome back. And that just failed with the no debug. So, knowing how many blocks it's failing at it's not consistent. So it's not giving me any useful data. So what I may end up doing, and I'm actually going to do this right now, is I am actually going to go through and I am going to remove or comment out the fprint statements. Yeah, I'm going to comment out the fprint statements, but so I'm not going to have pretty much any feedback from the program right now if it is failing. So if it does crash, so because I'm running that program right now, I can't do it on the fly, or I can't do it ahead of time. So the next time it crashes, I am going to compile it and rerun it. And I'm going to basically have to go by I may have to put in a signal handler for the seg fault so I can get how many blocks it was at to see if that gives any indication. Otherwise, the only indication I will have is the time, which is not as accurate. But right now we are at about 50 minutes into this live stream. So when I do run it, I'm going to have to note the time. And then I'm going to have to look back at the live stream to see how long each time, if it got any better or any worse. Or maybe it won't seg fault at all and we can just be done with it. So I'm going to say roughly 15 minutes. And we should be good. And it's 83 degrees in my office, so I don't know how much longer I'll be able to do this. So I did know that it crashed, and I don't have a time when it crashed. So right now, okay, so right now it is I'm going to say 6:07. So at 6:07, I'm going to put down what this program was at, and hopefully when it crashes, I have the foresight to check the time. So yeah, and if you hear the fans are starting to kick in because I'm up to like 83 centigrade. And the time right now is about 4 minutes and 22 seconds. I'm going to round this off to probably the quarter minute because that's not as critical. And this is taking a lot. Okay, so 4:45. Okay, so at least now I have a start time. So if it does crash again, I'm gonna have to try to double check or whatever, figure out the time. So I've started it at a roughly 6:03. Yeah, so that's what 6:03. Again, getting a rough benchmark. That's, yeah, I don't know if that's gonna add to the complexity, and other things is to run it with time and see if let time command and see if that affects anything. But another thing that can be done is that every, say, 7 minutes, it's the program itself is seg faulting. So if it's not the fprint buffer, then it is a issue with the main buffer, which I'm almost positive that I ended up Hold on, let me make sure that I ended up malloc-ing it. Yes, it's now malloc, and I actually did add a buffer to it. Why I added a buffer to it, I don't know. Well, basically I do know. I'm not sure if when you run the read command from the stream, if it has any padding on it, any metadata, anything like that. So I do want to make sure. Okay, I'm at 670 blocks, which was about where I crashed last time, so this could be any minute. So I don't know if, and I lost my train of thought. I don't know if the block size, if I make it exactly. So what I'm doing is making the mallet space 512K plus 12 bytes. I just picked 12 for no particular reason. But I am only reading each time through the buffer 512K. So if there is anything that gets fed off, that's why I was trying to see if that may be causing the seg fault. And if we get to an hour, so at 6:15, if this does not crash again, I am just going to figure this out later. Or I may just cause it to crash. So let's see. This is the what? This was the 5th crash in an hour. So let's just average that. Okay, so it did crash again. I was able to compile it. Let's see, do I have any information on when it crashed? About 9 minutes. So yeah, so 6:12. So 9 minutes. Okay, so I am going to I have a stopwatch running for charging the battery on my car. It's been going for about 2 hours, but I'm going to set this to 9 minutes. And once that goes off, if we are still going, then I'm going to say I'm going to probably try to go to at least 15 minutes, and it did seg fault again, right? Yep. So something's causing it to seg fault, and I don't know why, and it's too temperamental to try to run something like GDB and go step, 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 because this would be thousands of steps, because it's going to several hundred versions, and there's 5 or 6 steps. And if this is an issue where it is seg faulting somewhere inside of the RTMP library, then that doesn't help me. But if it's seg faulting with printf, then it would be seg faulting somewhere inside libc, which I wonder if I can. wonder if I can duplicate that by just making a program that is reading from a buffer. It's just, I'm going to make a 2 gig file and just, it's going to read from the buffer and write to the pipe, which will be basic. Yeah, it's going to write it to the pipe, and I'll have that pipe going to dev null. So it's just going to be flushing the data. And I could reverse it where it reads in the data, but still I need to send it somewhere once I well, no I don't. I could read in the data, and I still can use FFMPEG, and I could read in the data from the pipe and just not do anything with it. Then again, it could be the read command that is causing the issue. Oh, and now I got a bunch of errors because I'm not using block number. So let's see. So inside the while loop, it fread. That's, yeah. So fread, I can read from the pipe, and then with that data, I can just flush it or just ignore it and just read another thing. And yeah, I'm not running printf or anything like that right now, so that will alleviate some issues. But I still would want to know how many blocks are being sent. So maybe I can, inside the GUI, that's what I could do. If it's an issue with the FFmpeg, once I integrate the GUI, I can make that block number something that I can feed into, something I can feed back into the GUI. So somewhere on the user interface, I could have a block number listed there. And then eventually just say, by each block number, I will just multiply it by 512K. And that will be how much data was sent, and I can use that. Which right now I've sent 745K megs, 780 megs, according to FFmpeg. So there's a couple things that we can go through and get working, but I'm not overly concerned at this point. Yeah. But if one of the two people or both of the two people that are watching right now want to leave a message in the chat, go right ahead. Otherwise, if you're watching this after the fact, well, two people watching right now, thank you. But if you're watching this after the fact and you've gotten this far of me rambling, thank you, and leave a comment below. So I have a couple shorts that I want to make. One is about the dumpster fire that is Twitter. And another one is be asking for a name for the program. I think maybe a short would get more traction than the poll because the poll is not getting any traction, and I don't know how to promote. Well, it's not even a poll. It's a community post asking for suggestions because I don't even have, excuse me, I don't even have any suggestions at this point to put into a poll. And we are at, right now, at the sound of the tone, we are transmitting, or we are broadcasting for 8 minutes. Beep! And it is still 83 degrees in my office. And we are, yeah, we're at 8 minutes. If we get to 9 minutes, we will have succeeded further than we have. Because, yeah, so we crashed, what, 5 times in 60 minutes. So that's an average of 12. So again, 15 minutes we will be well ahead. Okay. So 9 will be shorts. Twitter, project name, and we are at 9.5 minutes, so we've gotten that far. New York City's water billing and how it's not conducive to save money. Well, this is its own video. I do want to make a video on Social Security. And that has been 9 minutes according to my clock or my phone. And yeah, I did stop that. And it's been just over 10 minutes according to the FFMPEG. Yeah, because it's, yeah. Took a couple seconds to compile, or about a minute to compile everything and get it back up and running. Luckily, the stream did not end, because after a certain amount of time, the stream ends. Okay, I have this, I put this back. Maybe I should cool off with my fan. See. I don't have my light. My light is someplace else right now. So let's see. What is the voltage for this fan? Maybe if I clean this. Yeah. Okay, grab onto that. Maybe. And try to get. I think I'm making this too complicated. Just says it's DC brushless. I can't figure out what the voltage for this is. It's probably 3.3. If I would imagine that's... Yeah, I'm assuming it's 3.3, not a 5-volt motor. Yeah. That's something I will check out at a later time. And we are up to 13 minutes. Woohoo! Let's go ahead and put this back without hitting the camera or knocking everything down. Okay. I will put this back after the live stream because I am dropping everything. And it's really, really warm in here. I don't know how much longer I'm going to be able to... I am sweating. Hold on, let me get a drink of water. Okay, so if this is indeed the issue, the printf, I am going to need to figure out why that is. But I may just circumvent it and get back to the why at a later time because I don't know. So that may be my next video demand or regular long form video that isn't a live stream. Will be showing basically this working and then not working with the F print. So that is actually very interesting. But now I need to figure out how to do that because I do use FFMPEG currently to do my screen recording. Actually, any of my recording. So what I could do is do the testing as part of a unpublished live stream, download that, and then edit that into a video. That could be a possibility. So we are at 16 minutes, which I think is the longest we've gone, and 750 megabytes. Let's see if we can get to 1 gig. And it crashed just at 16, a little over 16 minutes, but I did not get a seg fault. So that could have been an issue with FFmpeg, which, let's see if I can get any data. Error writing trailer of pipe broken. AV interleave right frame broken pipe. Is that what I was getting before? Error writing trailer. Yeah, so the interleave frame, AV interleave frame right, which it is what it is. And we are at an hour 15 on this. It is 6:30, at least Eastern time right now where I am. So I am thinking of ending this and then just going on and continuing the testing. So let me just run some more tests. So once it processes this video, it should clear at probably an hour 10. And yeah, so that's pretty. Okay, so like I was saying, it is 80, now it's 84 degrees in my office. So I'm going to turn on the AC so you can hear what that sounds like. And it's actually not oh yeah, it is kind of loud. So I would have to figure out a filter for this to get it to not crap out. So the last time it did just crash. So it did crash and it did give me a seg fault. So I reran it with the same option with the RTMP without the debug symbols. So I'm going to go ahead and cancel that. So I just restarted it without debug symbols. And we are back. And I was going to end this, but I want to see if I run into any issues. So this happened just as I was bringing the camera here. And I don't know if it had something to do with that. Because in the past, not on this machine, but on my Mac, which is right next to me, if my hand got too close to the camera buffered. And when, oh yeah, I have the AC on. Yeah, let me go turn that off because I wasn't planning on keeping this going. Sorry about that. So what I was saying is that with the Mac, if my hand got too close to the camera would lock up. And if you look at some of my older live streams from, when are they from? Let's see, live streams. Yes, so from about a year ago, I would do it, and what was happening is it seg faulted again, so I'm gonna have to do some testing. And this seems to be part of the issue, is the longer the live stream goes, the more likely it is to crash. So what I was saying is that if I put my hand up in front of the camera, it had a tendency, that plane's kind of loud, had a tendency to crash. So I'm testing that right now, and I can get my hand all the way up there and it's not. Maybe it's the movement. Okay. That's not it. Okay. So, like I said, it's getting warm in here. Getting warmer by the minute. Well, by several minutes. So, go ahead and subscribe if you haven't already subscribed. And, whoops, where was I? Sorry about that. And you can check out some of these other projects that we are doing. And also, if you have any other suggestions, put them in the comments. So you can subscribe, you can comment. I really should finish coloring these in. But yeah, if any of the content you like, or if you like the content, like it. And if you think somebody else would, share it. Yeah, I think my brain is fried. It's been a long week. So I'm going to go ahead and end this with the countdown video. And once this is processed and oh yeah, that reminds me. That is something I was going to test. So as soon as this live stream is done, I'm going to see if I can add end screens. And why am I going to do that? Because I was going to test that because I was discussing that, or I mentioned that to Sean Powers on his live stream because he had used it to lead into another live stream or into a premiere. So I wanted to see if you can add the end screen to that. So I'm going to go ahead and add the video and I'm going to test that out.